Dear students, this session we are going to study about mathematical expectation. Right? There are two cases. One is continuous, another one is discrete case. Okay? If it is continuous, then let x be a random variable with the PDF f of x, then its mathematical expectation is denoted by e of x and is given by e of x equal to minus infinity to plus infinity x into f of x dx. Okay? In the case of discrete, suppose x be a random variable with a probability mass function pi, where I running from 1 to 3 up to n, then the mathematical expression is given by e of x equal to I running from 1 to n xi into pi, right? So here integration, okay, x into f of x. Here xi into probability function, xi into probability function, that is expectation. Okay, right. Now moments. The rth moment with respect to origin is defined as, okay, mu dash r. The rth moment is denoted by like this: mu dash r is equal to expectation e of x of r. E denotes here expectation e of x power r. Okay. Suppose r equal to 1, right? Suppose r equal to 1, mu dash of 1 equal to e of x power 1 here, right? That is e of x. That is equal to mean. That is first moment with respect to origin. Okay, then suppose r equal to 2, then become mu dash 2 equal to e of x square. Second moment with respect to origin. R equal to 3, that is mu dash 3 is equal to e of x cube. Third moment with respect to origin, suppose r equal to 4, that is mu dash 4 equal to e of x power 4. That is fourth moment with respect to origin. Okay, right. Note, now rth moment with respect to any point. Okay, the last one is a moment with respect to origin, but here this is any point, that is mu dash r equal to e of simply x minus a, where a is a any point. Okay, power r. Right. Now central moments, another important definition here is central moments, that is moment about mean. First one is moment about origin, this one is moment about a point, this is moment about mean, right? That is mu r equal to e of x minus x bar. Here x bar is mean. Okay, r power r. X bar equal to mean, simply e of x. What is x bar here? E of x. Okay, now notes. Suppose r equal to 1, mu 1 equal to 0. That is moment, first moment here is 0 here. R equal to 2, mu 2 equal to e of x minus x bar the whole square. Right, so here this is said to be variance, right? Okay, r equal to 3, that is mu 3 equal to e of x minus x bar the whole cube, third central moment. R equal to 4 means mu 4 equal to e of x minus x bar power 4, fourth central moment. Okay, now properties of expectations and moments. Okay, so here the first property of moment is mu1 equal to e of x minus x bar equal to 0, right? So mu1 equal to e of x minus x bar, okay, by definition here, right? Mu1 equal to x minus x bar here, right? If you put r equal to 1 here, become x minus x bar power 1, right? X I running expectation. So formula here we are going to apply discrete case, right? We can apply either continuous case or discrete case. So here we apply discrete case. I running from 1 to n. So e of x minus xi. What is the formula for e of x? Simply xi into pi. Instead of x we have xi. Instead of x minus x bar we have xi minus x bar into pi, right? Now multiply by pi. Separate the summation. Okay, what is this? This is x bar, right? So what is this? This is also x. X bar is constant here. Bring outside. Summation I running from 1 to n pi. That is sum of all the probability is 1. Now x bar minus x bar becomes 0. Therefore mu1 equal to always 0. Now this is very important derivation. Prove that variance of x equal to e of x square minus e of x the whole square, that is mu2, right? So here we are going to prove variance of x, that is mu2 equal to e of x minus x by the whole square. Mu t is simply variance of x. Apply a minus b whole square formula, x square plus x bar square minus 2x x bar. Okay. Now apply expectation only to the variable x. Right. So here e of x square, simply e of x square minus 2 into e of x into e of x bar, because expectation of c equal to c. We are going to prove this proof, right? E of x square. So this is e of x the whole square minus 2 into e of x s bar equal to simply e of x. Now after simplifying we get this result, right? Now properties, e of c equal to c, e of ax plus b equal to a into e of x plus b, right? So prove e of c equal to c, e of c equal to, so formula for this is xi into pi. Instead of x we have c, just to replace xi by c here. C is constant, I take away. I running from 1 to some number pi. Summation, sum of all the probabilities 1. C into 1 is C. Therefore, E of C equal to C. Same thing here. Prove E of AX plus B equal to E of EX plus B. Right? Apply definition. I running from 1 to some number AXI plus B into PI. Multiply by PI. Okay. Take constant away. Sigma xi pi, take constant away, sigma pi. So this is E of x formula. Sum of all the probability is 1. Okay, we get this result. Next, variance of c is 0. What is the formula for variance of c? Variance of x is the formula for variance of x. Replace x by c. Right, put here. E of c square simply c square. E of c is also c. So c square. C square minus c square is 0. Prove that variance of ax plus b equal to a square variance of x. Okay. Now, variance of ax plus b equal to x minus x for the whole square. We are going to use this formula. Okay. Variance of ax plus b equal to simply ax plus b, e of ax plus b the whole square. Okay. Right. Now, this is ax plus b. Now, apply expectation, become a e power x plus b is there. Simply b. Minus is there. So, put minus in both sides. So now cancel b, then we have taking a away become a square x minus x power the whole square. A square is constant, therefore take away here a square. So this is variance of x. This is the formula. Okay. Similarly, we can easily prove variance of x plus c equal to simply variance of x. Very simple proof. Next definition. Moment generating function. Let x be a random variable. The moment generating function x is given by mx of t. Okay. About origin is e of expectation of e power tx. Okay. About mean is e of e power t x minus mu. Here mu equal to mean, right? So there are two type of formula here. Okay. One is for discrete case, another is for continuous case. In the case of discrete, moment generating function is e power tx. So if it is discrete, apply summation e power txi into pi. If it is continuous, apply integration e power tx into f of x dx, right? Okay. Now we are going to see some problems. The cumulative distributive function of an random variable x is capital F of x equal to 1 minus x plus 1 e power minus x for x greater than 0. Find PDF, mean variance. Okay, right. First one is PDF, that is probability density function. So we can directly find PDF from cumulative. Simply differentiate this with respect to x. So PDF formula here is differentiation of cumulative distributive function with respect to x. Now differentiate this with respect to x. This one becomes 0. Leave this. Minus, apply UV formula here. This is u. If we differentiate this, we get e power minus x minus 1. Plus, if we differentiate this, become 1 e power minus x. After simplification, cancelling the common term, we get f of x equal to x into e power minus x. So there is a lot of difference between a small f of x and a capital F of x. Small f of x refers probability density function, whereas capital F of x refers cumulative distributive function. Okay. Next, second question is mean. Formula for mean in the case of continuous is e of x equal to minus infinity to plus infinity x into f of x dx. This is standard formula for e of x in continuous case. Okay, what is f of x here? X into e power minus x. Put here. x into x become x square e power minus 6 dx. Okay, we have minus infinity infinity, right? But here when x greater than 0 only this formula, when x greater than 0 means simply 0 to infinity this formula, otherwise it is 0, so takes 0 to infinity instead of minus infinity to infinity. Okay, formula for this is 0 to infinity x power n minus 1 e power minus ax is simply n minus 1 factorial by a power n. Okay, so put here 2 here, therefore 2 factorial by 1 cube equal to 2. Apply this formula here. Right now, to find the variance of x, the formula is e power x square minus e of x the whole square. Okay, but we should know what is e of x square. We know e of x equal to simply 2. 2 square become 4. We have to find this. For this, e of x square equal to minus infinity plus infinity x square f of x dx. Again, substitute f of x equal to x into e power minus x become x cube e power minus x. Apply formula 3 factorial by 4. Apply the same formula. This formula become 6 here. Put 6 here. 6 minus 4 is 2 here. Okay, is the problem. That's all. Now second problem. The probability mass function of a discrete random variable x is given in the following table, right? So x is given like this: minus 2, minus 1, 0, 1, 2, 3. P of x equal to x 0.1 k, 0.2, 2k, 0.3 k. The question here is find the value of k, probability of x less than 1, probability of minus 1 less than x less than 2, e of x, variance of x. Okay, first we are going to find the value of k. For this we are going to apply sum of all the probability equal to 1. So here this statement is wrong here. Okay, sum of all the probability equal to 1. That means sum of all the probability, add all the probability, that is equal to 1. After simplification, can easily find k equal to 0.1. After finding k equal to 0.1, substitute the value here. So we get the new table. Okay, so first one is, second one is p of x less than 1. So less than 1 means less than 1. So 0, minus 1, 2, 3. That is p of x equal to minus 2, x equal to minus 1, p of x equal to 0. Less than 1 means don't include 1 here. Okay, add all the values, we get 0.4. Next one is p of minus 1 less than x less than or equal to 2. That means from minus 1 to 2. Don't include minus 1 also. So 0, 1, 2, 0, 1, 2. Add all the values, we get 0.7. Next one is expectation e of x. Formula here is summation xi pi. Okay, that means this is x into p minus 2 into 0.1 easy, minus 2 into 0.1, minus 1 into 0.1, 0 into 0.2, 1 into 0.2, 2 into 0.3, 3 into 0.1 likewise. Okay, now after simplification we can easily find e of x equal to 0.8. So next one is we are going to find the variance. To find the variance we should know e of x square. Formula for this is simply replace this by x square. Okay, squaring means simply square this number. Minus 2 square is 4 here. 4 into corresponding probability here is 0.1. Similarly square this. 1 into 0.1. Similarly square this 0 into 0.2 likewise. Okay, that is 2.8. What is variance of x? E of x square minus e of x the whole square. E of x square is 2.8 minus what is e of x the whole square? 0.8 the whole square. Subtracting we get 2.16. Okay, right.